In this project, I will demonstrate how to use I2C for water level sensor reading. We can use this quick start guide document to get the pin numbers for I2C connected to Arduino interface. We will use this water level sensor from Seed Studio. This sensor has two I2C slave devices. To read water level, we need to read both slave 80 tiny devices. Here they have provided an example for Arduino IDE. In this video, we will recreate this example in ESK Studio using FPB-RA0E1 board. Open ESK Studio and click on this file icon, then select New, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this Next button. Here from this drop-down menu, select FPB-RA0E1 board. After board selection, click on this Next button. Here select Executable and No Autos option. Then press Next button. Here select Bare Metal Minimal and click on Finish. IDE will take some time to load your project. In FSV configuration file, click on Stack tab, then click on New Stack, then click on Connectivity. Here select I2C Master Stack. Now click on I2C Master Stack, then open Properties window. Here you need to change the duty cycle to 50%. Then scroll down to find GPIOs for I2C stack. For serial clock line, select 914, and for serial data line, select 913. After that, we don't need to change anything further. Click on Generate Project Content. Now IDE will generate source code according to FSP configuration file. Expand src folder and open hallentry.c file. Now I will add RTT source code in this project. Include common util.h file in hallentry.c file. Now we need to declare some global variable according to this example given on Seed Studio website. These variables include data buffers for I2C reception and I2C slave addresses. After that, we need to define a function to read data from 80 tiny high address I2C slave device. I am naming this function as read high ADDRIC. After that, we need to define a function to read from low ADDRIC. After function definitions, you need to provide the function prototype. Now copy both function names and provide their prototype up here. First, we need to use memset to initialize array with zeros. Now in Project Explorer tab, expand Developer Assistant tab, then expand I2C Master stack. Now drag and drop I2C Master slave address set function call in hallentry.c file. Now declare FSP error variable to check the function call. Now use assert function to make sure I2C master slave address set function call was successful. In assert function, check if status is equal to FSP success. Now you can use 80 tiny high address in second argument of this function call. For third argument, you need to specify the address mode. Now you can type I2C underscore master, then press Ctrl plus spacebar to get suggestion related to predefined macros. Here you need to select I2C master address mode as 7-bit. Now from Developer Assistant tab, drag and drop I2C master read function call in hallentry.c file. Now again use assert function to make sure I2C master read function call was successful. Now we need to specify the destination buffer where we want to save the incoming data. Use high data array here. After that, we need to specify the number of bytes. We want to read 12 bytes here. Then we need to set the reset as false. Now if we open FSP documentation for I2C master stack, here they have provided an example for how to wait for reception to get completed. Now copy this example in hallentry.c file. For this example to work, we need to define two variables. First one is timeout variable. The second one is I2C master event variable. Define these variables in global space. I am using 3-second delay for reception to get completed. Now from Developer Assistant tab, drag and drop callback function in hallentry.c file. By using p argument variable, you can update the event variable accordingly. Now I will read the low address 80 tiny device. Use memset to clear low data array. Now from developer assistant tab, drag and drop I2C master slave address set function call. Now here again you need to define FSP error variable. After that use assert function to make sure slave address set function call was successful. Now you can copy the low address from here that you can use in second argument of the address set function call. For third argument, you can use I2C master address mode 7-bit. Now from developer assistant tab, drag and drop I2C master read function call. You can use the above example to wait for reception to get completed. For second argument in I2C master read function call, you can use low data array. For third argument, according to example, we need to read 8 low data bytes. Now you can use RBSP software delay to introduce 100 millisecond delay after both function calls. For first argument use 100 and for second argument you can specify BSP delay unit milliseconds. Now I will declare another function name as measure to calculate the water level according to data read from I2C. After function declaration you need to provide function prototype up here. After that according to this example we need to declare these variable here. After that, according to this example, we need to read data from both ICs. For that, we can use our read function call. First, you need to call read low ADDR IC. Then you need to call read high ADDR IC. Now we can use print function to log data on RTT terminal. First, we will print the low data array on RTT terminal. To print low data bytes, we can use for loop with 8 iterations. In for loop, first we can print the low data array value, then we can print a dot character, then we can check for if the value is in between low and high threshold value. If that is the case, we can increment the low count. Now we can use print function to log high data array value on RTT terminal. Use backslash and escape sequence in print function to format the output on RTT terminal for high data array byte. Now again we can use for loop with 12 iteration to print high data array on RTT terminal. First print the high data array value, then we can print the dot character. After that you can check if the current high data array value is in between the low and high threshold. Now according to this C Studio example, we need these two for loops to calculate the touch value for high and low data array. Now, according to this example, I need to have a while one loop in the measure function. For that, I can declare a while one loop here. Now, I need to cut these instructions and paste them under the while one loop. Now, according to this example, I need to declare these two variables in while one loop here. After declaration, you can observe the error is removed from the last two for loops. Now according to this example, we can use print function to log water level threshold on RTT terminal. After that, you can use RBSP software delay to introduce 1 second delay between each reading. Now in Project Explorer tab, expand I2C master stack. Now you need to drag and drop I2C master open function code in hard entry function. Now use FSP error variable and assert function to make sure I2C master open function call was successful. After that you need to call measure function. Now you need to build your project. For that you can click on your project name, then click on this hammer icon to build your project. We have some warning related to print function. We need to use %d escape sequence when printing integer values on RTT terminal. Use %d escape sequence when printing the trigger section value. Now again use %d escape sequence when printing high data array value in for loop, and again when printing low data array value. Now again build your project. Now I will explain this program in detail. This sensor measures water level by using a capacitive touch sensing method using two I2C slave devices. This sensor is divided into 20 equal regions. Each region represents 5% of water level rise. First 8 capacitive touch sensing regions are read by low address I2C slave device, and remaining 12 regions are read by high address I2C slave device. Every region have a further range of value from 0 to 255. 0 mean no water level is present, and value from above 250 mean water have risen above this level. These unit 80 values are read by I2C in low and high data byte. Now using for loop we can check if the water have crossed the threshold value of a particular region. Then we can right shift 1 into touch value variable. Then using bitwise AND operation we can check how many capacitive touch region have value above the threshold value. If a region have value above than threshold value, then we can increment the trigger section variable. Now by multiplying the trigger section variable, we can get the water level in percentage. After a successful build, right click on your project name, then select debug as, then select Renesas GDB hardware debugging. After that, IDE will ask you to switch to debug perspective. Click on switch button to switch to debug perspective. In debug mode, click on this resume button twice. Before submerging the water level sensor in water, make sure it is clean and dry and have recorded a 0 level. Then you can submerge the sensor in water to get the water level reading values. Now as I submerge the sensor in water, you can observe the low data and high data values are changing from 0, and the sensor is showing that we have reached almost 60% of the threshold value. For experiment now, I will move sensor up and down in container to get different reading. Also, you can use \n escape sequence here to get sensor value in new line.